Hello, welcome to Zigmatech Learning Hub. I will be your instructor for mathematics. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GC, KCPE, IJMB, JUPEB, KCPE, BECE, SSCE, NCEE, and NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class, okay? Let's get started. You're welcome once again to today's class. It's a continuation of probability, part 2. At the end, we're expected to know the meaning of what mutually exclusive events, then use the tree diagram in problem solving. Mutually exclusive events, when the occurrence of a particular event has no effect on the other event to occur. We said they are what? Mutually exclusive. If event A occurring has no effect on event B to occur, both A and B are mutually exclusive. Look at this question now. Find the probability that a letter chosen at random from the alphabet is either a vowel or one of the letters X, Y, Z. To handle this problem, you must know what a vowel sounds, how many they are in the letter A, B, C, D. Now let us list out the number of vowels you have in A, B, C, D. So for vowel sound, V, the elements or the sample event for it, we'll have the A, O, E, I, and the U. A, O, E, I, U. Vowel sound. So, what's the sample event? How many are they? They are just 5. Now, the letter of the word, X, Y, Z. Let's say letters. X, Y, Z. The mother set in this thing you are seeing here, that is A, B, C, D, A to Z, let's say universal set, A, B, C, D, E, dot, dot, dot to Z. We know that we have 26 alphabets. Now the question, the probability for a vowel sound and one of the letters X, Y, Z, meaning V union L, one of the letters, equals A, O, E, I, U, X, Y, Z. This is to say that probability for vowel sound, P of vowel, P of V equals 5 all over 26. Then PR of the letters X, Y, Z, 3 all over 26. Now, PR of V or L equals 5 all over 26 plus 3 all over 26. This will not give us 8 all over 26. 2 here, 4, 2 here, 13. So PR, probability of vowel sound or letters of the word X, Y, Z equals what? 4 all over 13. 4 over 13. Question number 2. Find the probability that a letter chosen at random from the alphabet is a vowel. It's a vowel. Vowel. Now, we have listed it from the first question. The vowel sound. So probability of the letters being vowel sound or vowel equals, how many are they? Just 5. Total outcome 26. So the probability for vowel sound there is 5 all over 26. So the next thing, example 3. Find the probability that a letter chosen at random from the alphabet contains the name Christian. Contains the name Christian. You write down the name Christian. You now begin to count how many letters or alphabets are in it. One, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 letters. So probability of the name Christian equals 9 all over 26. So this is the solution to that question. As well, you can use your own name to solve probability or name of anything, provided it's containing the letters of the word, that is from the alphabet A to Z. It is possible to solve for its probability. We want to talk about the tree diagram. Tree diagram is just a way of solving probability using a diagram called the tree. But there are some rules you need to know. Be careful when the question is saying 3 times, 2 times, 4 times. It will not depict the number of diagrams you are going to draw. For instance, if a coin is thrown twice, the tree diagram for it is going to be, we believe that coin is always head and tail. You have the head, the tail. So if it's thrown twice, tree diagram 1, this is head, this is tail. Tree diagram 2, this way, the head, the tail, the head, the tail. That's all that. Now the sample event, this combining this combining this, head, 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 tail. This combining this, tail, head, tail, tail. So our sample event, head, 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 tail, tail, head, tail, tail, is what you are going to work with, assuming the question is given to you to solve. Likewise, you can use it for balls, like a bag contains this 4 red, 5 blue, whatever. How do you know the number of diagrams to draw? The number of balls that are involved, the colors of the ball, green, white, red, meaning they are 3. But that does not mean that you are going to draw 3 diagrams into 3 places, except the question says if it is thrown twice or it has been done 3 times without replacement. The beauty of the 3 diagram is the question of without replacement. For replacements, with replacement, we don't have any challenge about solving it. But without replacement, it's always challenging in nature. Let's see how we can solve some questions. Example 1. A bag contains 3 black balls and 2 white balls. Find the probability A ball is taken from the bag and then replaced, and a second ball is taken from the same bag and then replaced. What is the probability that they are both black? That's 2 of them are black. This one, the first ball was taken. The question is not without replacement. The question is with replacement, because they say it is replaced. So the way you handle it, you need to be careful with the statement. A bag contains how many? 3 black balls, isn't it? And 2 white balls. First thing here, you determine the number of balls in that bag. What are the number of balls? I have 3 black balls. We also have 2 white balls. Which is going to give us 3 plus 2 equals what? 5. At least we know our total outcome now is 5. Now, a ball is taken from the bag and then replaced. A second ball is chosen. What is the probability that both are what? Black. A ball is taken from the bag and the second one is chosen. What is the probability that both of them are what? Black. Okay, from 3 diagram, we can still use the other method. We'll have the black balls and the white balls. So for black, 3 over 5. For white, 2 over 5. Now they said it is being replaced, meaning it's not without replacement. So we maintain the normal numbers. We'll have, this is black, this is white. For black, 3 over 5, then white, 2 over 5. Now the question is that both are black. Where are black? That is black, black. Say it, sample space, BB. This to this, and this to this. This is BW, black, white, and the white, black, then white, white. Now we have these things. The question is the probability that 2 of them are what? Black. I think it's easy. It's looking at you there. See it, see black, 1, 2. So probability of both being black equals 3 over 5 multiplied by 3 all over 5 to give us what? 9 all over 25. Because the ball was replaced. So it's 9 all over 25. Let's see the next question. 1 is black and 1 is white. Come back to the diagram. 1 is what? Black and 1 is white. We have either the probability of black coming first before white or white coming first before the black. Remember the meaning of or in probability is what? Addition. Y and means multiplication. So 1 is black and 1 is white. Okay, in this case, we're going to have PR of 1 black, 1 white, or white, then black. This will give us, for BW, we'll have CB, CW, that is black, white, 3 over 5 multiplied by 2 over 5, or white before black. What is white? C black. 2 over 5 multiplied by 3 all over 5. So this will give us 6 all over 25 plus 6 all over 25. This will give us 12 all over 25. So the probability of getting 1 white and 1 black equals what? 12 all over 25. The next question, at least 1 is black. This is where the challenge is in probability. Your ability to interpret the word at least, at most, matters a lot. Now let us see how we can interpret such a question when it is given to us. We already know our total number of blacks, total number of whites. So now we are faced with at least 1 black. At least 1 means from 1 to the highest number of black that occurred. So how do we figure it out? 1 black, I can see black here, or I can see black here, or I am seeing black all through. That's the meaning of that question. From 1 upwards. Then at most means exactly that thing they are talking about. If they say at most 2, from none to exactly 2, or from 0 to exactly 2, we'll handle it. I'll get to that case of at most. But let us finish with at least. So, probability of at least 1 black equals probability of white black, or probability of black white, or probability of black black. It's easy. So we'll have that PR of white W, white black, 2 over 5 multiplied by 3 over 5, or 3 over 5 multiplied by 2 over 5, or 3 over 5 multiplied by 3 over 5. This is all we need for this question. So we have 6 all over 25 plus 6 all over 25 plus 9 all over 25. So our LCM here is just 25. So 6 plus 6 plus 9 will give us, this is 12. 12 plus this 9 is 21. 21 all over 25. So the probability of at least 1 black is what? 21 all over 25. That is the probability of at least 1 black. At most 1 black, go this way, IV. At most 1 black, meaning there is no black and just exactly 1 black. Meaning it's going to be probability of white white, white, black, black, white, but not black, black. Or you simply say, just save yourself the time, 1 minus at least 1 black will give us at most. Let's see. Let's check it from here first. Then we'll not try the other way around. PR of white, white plus PR of white, black plus PR of black, white, but not black, black, to give us 2 over 5 times 2 over 5 plus 3 over 5, 2 over 5 times 3 over 5 plus 3 over 5 times 2 over 5. This will give us, this is 4 over 25 plus 6 over 25 plus 6 over 25. So, this will give us 16 all over 25. 16 all over 25. So the probability of at most 1 black is 16 all over 25, or the probability of, that's 1 minus at least 1 white. At least 1 white will give us at most 1 black. 1 minus the probability of at least 1 white will give us the probability of at most 1 is black. So if you want to do it that way, that's white, white all through. You go that way. Like we know, our white is 2 over 5 times 2 over 5, which will give us what? 4 over 25, okay? Now, you don't want to stress yourself. Just say the probability of at most 1 black means 1 minus the probability of all white. That is, all white here, 1 minus 2 over 5, 2 over 5, 4 all over 25. This will now give us 25 minus 4 all over 25 equals 21 all over 25. So it will give us the probability of who? At least 1 black. But if you want to get the one for at most 1 black is 1 minus white, white, black, black. Our black, black is 3 all over. Let's check that one. At least you can see other means of getting that same question, that same solution. 1 minus probability of black, black will give us at most 1 black. So what is probability of black, black? 3 all over 5 times 3 all over 5, which is 1 minus 9 all over 25, which will give us 25 minus 9 all over 25 equals 16 all over 25. You can see that they are the same. So it's your choice. I don't know the one you prefer, but anyone can still serve you better. All you need is carefulness. Let's look at the one that will have 3 questions in it. So a bag contains 3 black balls, 4 white balls, and 5 red balls. 3 balls are removed without replacement. What is the probability of obtaining 1 of each color? This one is without replacement. It's no longer with replacement. We solved with replacement. Now we're not talking about with replacement. So for this without replacement, care needs to be taken, and we'll have three things here. So what are they? A bag contains 3 black balls. We'll have 3 blacks, then 4 white, and 5 red. So total number of balls, this plus this, is 12 balls. We'll quickly draw. 3 balls are removed without replacement, meaning 3 times. Okay, we're going to make a provision for it. The first ball here, let's start this way. Second, remember we are dealing with 3 different samples. Okay, whereby this will now go again. On a separate direction. Separate direction. Now we'll call the first one. Look at the box. I have black. I have white. And I have red. If here is black, it means black is here again. Black, white, red. The owner here is white. So black, white, red. The owner here now is red. Black, white, red. The owner here is still black. Then black, white, red. The owner is still white. Black, white, red. The owner here now is red. Black, white, red. Here, black, white, red. This is white, black, white, red. This is red, black, white, red. Okay, this is the diagram. But the next thing we're going to do, how do we fill in the numbers? That's another case. So the question says without replacement. Now, recall you have how many blocks? We have 3 blacks, 3B, then 5 white, and 5 reds, 4 white. But we are dealing with total of 12. So for black, come here, 3 all over 12. For white, is what? 4 all over 12. For red, 5 all over 12. Just watch what I'm doing. The way I'm doing it. Now, you were told it is what? Without replacement. I am moving now. I want to move the plaque. Remove the plaque from here now, so it can come to this place. Since the buzz here is black, meaning it will affect the numerator and denominator, meaning 2 over. Okay, you can see we are done with the first phase, which is just the normal number. To get, we want to remove black. If you are to remove black, the numerator will be affected, denominator will be affected by 1. That is 2 over 11. Because black is the owner of this place, this lane. So the rest, only denominator will be affected. So for red, 5 over 11. The same thing this way, the owner of this lane is white. So it's only white will be affected at the numerator and the denominator, but the rest, only denominator will be affected. Likewise, the owner of this lane now is the red. So only red will be affected at numerator by saying 4 over 11, while the rest is only denominator, 4 over 11, 3 over 11. So we are done with this. Let's go to the next movement. Still, the owner here is still black. So numerator will be affected, denominator will be affected. But for this person, the white, only denominator. Red, only denominator. The owner here is white, so numerator will be affected, denominator affected. While this gentleman here, the black, only denominator. And the red, only denominator. The owner of this place now is red. So while maintaining the numerator of black and white, the numerator and denominator of red will be affected. So the owner here now is black, so numerator affected, denominator. The rest, only denominator. The owner here is white, so black will maintain, numerator affected, denominator affected, only denominator. Then here, the owner is red, numerator affected, denominator affected, the rest, only denominator. Likewise here, the owner is black, numerator affected, denominator affected, here the rest, only denominator. Here the owner is white, so numerator affected, denominator affected, but the rest, only denominator for the rest will be affected. 3 over 10, then 4 over 10. The owner here is red, numerator will be affected, denominator affected, while the rest remains the same. Only denominator. So if you watch very well, in each of these labeling, you can see a similar number coming up. 4 over 10. How many times? Twice here, twice here. 3 over 10. How many times? Twice here, twice here. Then look out for 2 over 10. 2 over 10 in each. This 2 over 10 is also here. Okay, let's go straight to the question. The question is, what is the probability of obtaining 1 of each color? 1 of each color. Okay, let's list. I will have black, 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 white, black, black, red. Here now, black, white, black, black, white, white, black, white, red. Here now, black, red, black, black, red, white, black, red, red. Here now, white, black, black, white, black, white, white, black, red. Here, white, white, black, white, 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 red. Here now, white, red, black, white, red, white, white, red, red. Then here, red, black, black, red, black, white, red, black, red, red, white, black, red, white, white, red, white, red. Then red, red, black, red, red, white, red, red, red. You count how many of them you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. How do you know when you are correct? There is a formula in set theory. That is when you talk about the power of set, where you have 2 raised to the power n. But now, how many balls are involved is 3 balls, meaning this formula will no longer exist. It becomes 3 raised to the power n. Now, how many times are the balls were removed from this place? 3 times, meaning 3 raised to the power 3. Now, 3 raised to the power 3 equals what? 27. So, automatically, you are correct. Everything you have here is in order. That is how to know when you are right and when you are wrong. Now, at least, okay, 1 of each color. 1 of each color. 1 of each color. Let's answer it. We have 2 colors here. Just one color is what they're interested. Let's check. 1. 2 colors are here. Another one. White, black, red. White, white. This. White, red, black. Another one. White, red, white. No. White, red, red. No. Red, black, black. No. Red, black, white. Yes. Red, black, red. No. Red, white, black. No. Red. Yes. Then red, white, white. No. Red, white, red. No. Red, red, black. No. Red, red, white. No. Red, red, red. No. So how many of them? 1, 2, 3, 4, 5, 6. We have 6 of them. So the probability here now, this is your red, this is the black. The probability will have PR of who? Black, white, red plus PR of black, red, white plus PR of white, black, red plus PR of white, red, black plus PR of red, black, white plus PR of red, white, black. 1, 2, 3, 4, 5, 6. So, to detail the answer here, black, white, red Where is it? Black, white, red. Black, white, red. That is 3 over 12 times 4 over 11 times 5 over 10. You can see it. From the highest to the next is reducing. Plus this black, red, white. That is 3 over 12 times 5 over 11 times black, red, white, 4 over 10. Okay. Plus white, black, red. White, black, red. White is 4 over 12. That is 4 over 12 times white, black, red, 3 over 11 times 5 over 10, white, black, red, plus white, red, black, white, red, black, 4 over 12 times 5 over 11 times white, red, black, white, red, black, 3 over 10 plus red, black, white, red, black, white, 5 over 12 times 3 over 11 times red, black, white, 4 over 10 plus red, white, black, 5 over 12 times red, white, black, 4 over 11 times red, white, black, 3 over 10. So you are done with that. You just collect 3 times 4 is 12 times 5, which is 60, all over 12 times 10 is 120 times 11 1320 plus this is 20, 60, all over 1320 plus this is 20, 60 again, all over 1320 plus this is 20, 60, 1320 plus 20, 60 again, 1320 plus 60 all over 1320. 1, 2, 3, 4, 5, 6. So give us, how many 6 do we have? 1, 2, 3, 4, 5, 6. 180. 60 plus 60 is 180. 180 plus 180, 360. All over 1320. 0 here. So 2 here is 18. 2 in this is 61. So 18 all over 61 is the answer to this question. Here comes to the end of this topic, probability using a tree diagram. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.